As we have seen, computer hardware can only handle raw binary instructions. This is the language computer processors natively speak. In fact, it's the only language they are able to speak. It's called machine language or machine code. In the early days of computing, people had to write entire programs in machine code. More specifically, they would first write a high-level version of a program on paper, in English, like for example, retrieve the next sale from memory, then add this to the running total for the day, week and year, then calculate any text to be added, and so on. An informal, high-level description of a program like this is called pseudocode. Then, when the program was all figured out on paper, they would painstakingly expand and translate it into binary machine code by hand, using things like opcode tables. After the translation was completed, the program could be fed into the computer and run. As you might imagine, people quickly got fed up with this process. So by the late 1940s and into the 50s, programmers had developed slightly higher level languages that were more human readable. Opcodes were given simple names called mnemonics, which are followed by operands to form instructions. So instead of having to write instructions as a bunch of ones and zeros, programmers could write something like load A14. We used this mnemonic in previous courses because it's much easier to understand. Of course, a CPU has no idea what load A14 is. It doesn't understand text-based language, only binary. And so programmers came up with a clever trick. They created reusable helper programs in binary that read in text-based instructions and assemble them into the corresponding binary instructions automatically. This program is called, you guessed it, an assembler.